We're going to look at how to find the equation of a straight line. First of all, let's look at finding the gradient of a line. The gradient is a measure of the steepness of a line. The steeper a line, the bigger the value of the gradient. When a line slopes upwards from left to right, we say that it will have a positive gradient, a positive value, and when it's sloping downwards from left to right, it'll have a negative gradient. Parallel lines are sloping in the same direction, so they have the exact same value of the gradient. So what we need to do is think about how we work out the value of the gradient. A very straightforward, simple way of doing that is thinking about the vertical distance over the horizontal distance. So how far vertically over how far along horizontally. So if we look at this line here, we take any 2 points on the line, so 2 points where it goes through. You're looking at so from this point here to here, we could go further apart. Any 2 points in the line will calculate the gradient. So for this one, I'm going to go from this point here down to here. So vertically, it's sloping upwards from left to right, so we know it's going to be positive. It's got a vertical and a horizontal distance. So counting the boxes, it's 1, 2, 3, 4 up to here. So it's 3 boxes up the way and 1, 2 along the way. So our gradient M is vertical over horizontal, which is 3 over 2. Okay, it's 1.5 or 3 over 2. We can use a formula for calculating the gradient if we know 2 of the points on the line. The formula is the difference in the vertical distance over the difference in the horizontal distance, and we can convert that into y2 minus y1 over x2 minus x1, and the x's and y's are coordinates on the line. Okay, so any 2 points on a line, x1, y1 and x2, y2 can be used to find the gradient. It doesn't matter which 2 points you use as long as they're on the same line. So if we look at the blue line, we've got a point at 0, 0, and we've got another point at 4 along and 3 up. Okay, so 4, 3. So if we call them x1, y1 and x2, y2, then we just substitute them into our formula. So m becomes 3 minus 0, so 3 minus 0 over 4 minus 0, which is 3 over 4. And the good thing about the formula is it will automatically tell you whether it's negative or positive, whether it's sloping up or down. So this is given as a positive answer, a positive value, which is correct because that is sloping up the way, so we should expect a positive value. The straight lines should have an equation of the form y equals mx plus c. Now this is an important formula and you need to know this. So what we need to understand is the y and the x are various points on the line. M and c are constant. M is our gradient, it's the letter that we use for gradient, and c is the letter to describe the y-intercept. In other words, where the line cuts the y-axis. That value where the line crosses the y-axis. So when we want to find the equation of a straight line, these are the 2 bits of information that we need. We need the gradient and we need the y-intercept. So if we look at an example of a straight line where we want to find the equation, and we're going to do it using our simpler gradient method. So we have a line sloping down the way from left to right, so it is going to be a negative gradient, and it's important to recognise that when you are using the simpler form of the gradient because you have to remember to put that in. Okay, so y equals mx plus c, always good to start with that because that tells us exactly what it is that we need to find. We need to find our gradient m and our y-intercept c. So to find m, we are looking at our vertical, so it's going down, and this is what tells us it's negative as well. We're going from 8 down to 0, and then we're going along 6 boxes, or 6 spaces as well. So although it's boxes, each box is 2, so we've got to count how many from 0 to 6 is 6. So 8 down and 6 along, so our gradient is our vertical distance is minus 8, down by 8, and then horizontal is along by 6, and we can simplify that to minus 4 over 3. So that's our gradient. Our y-intercept, we can actually see, we can just pick that out here. It's crossing the y-axis at this point here at 8. So C is 8. And then all we have to do is put these two values into our formula. So our y equals mx plus c, we're going to replace m with minus 4 over 3 and c with 8. And we get an equation of that line as y is equal to minus 4 over 3x plus 8. We'll look at an example where we're having to use the gradient formula. So we can't really count along boxes here or anything like that. We've just been given a line and we've been given 2 values on the line. We've been given 1 point, which is 6, 12, and we're told here that the y-intercept is 8, which is good because that gives us a c value, but as a coordinate point, that is going to be 0, 8. Okay, so y equals mx plus c, so m, we're going to use these 2 points, 0, 8 and 6, 12. So x1, y1 and x2, y2. So x1, y1 for the first point, x2, y2 for the second point. So it's going to be 12 minus 8 on the top line and 6 minus 0 on the bottom line. So 12 minus 8 is 4, 6 minus 0 is 6. So that simplifies to 2/3. So 2/3 for our gradient. And our y-intercept, as we said, is 8. It's given here as being 8. So we can just put them straight into our formula. Y equals mx plus c. So that's y equals 2/3 x plus 8.